All right, everyone, let's get the show started. Welcome to our DevOps office hours. It's April 28th, 2021, and today we have a special edition of office hours where we're going to give a few demos. So my name's Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it together with your team while showing them the ropes. If that sounds interesting, head over to cloudposse.com/quiz to get started. Our call today is recorded. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. We host these calls every week. We'll automatically post a video recording of this session to our YouTube channel, as well as follow up with an email so you can share that with your team. So with that said, let's kick this off. The format of our call today is a little bit different. If you're regular, we're not going to be answering as many just off the wall questions. Instead, we have Matt Gowie joining us from Masterpoint Consulting. And Matt, he's been helping us with the documentation for everything we do here at Cloud Posse, including the revised tutorials now that we have for Atmos and the rest of the sweetops toolchain. And he's been using this in his own consulting practice, and he has really grown to like the tool set. So he's going to answer a couple really interesting questions here that we've received lately. One is, how does our README generator work, and how to use it, and what is it? First of all, like, why do we generate our READMEs? And then the next thing is Atmos. So Atmos is our one tool to beat them all to automate your infrastructure. Automates Helm file and Terraform to start with, but it's going to do a lot more than that. So Matt, you want to take it from here? You're muted, Matt.
There we go. So
we go.
Yeah, I was asking, can you all hear me all right? And then of course, no, you can't.
Hey, it worked.
Cool. So yeah, we're going to go through these two demos. I think we really just want to show some of the stuff that's behind the scenes at Cloud Posse, and kind of the stuff that they're open sourcing. And Atmos is a big part of that. And then of course the README generator is fun if you haven't like traced all the pipes through yourself. It's actually I knew how it was working from looking at it maybe a year ago, but I just redid it myself in preparation for this, and it's pretty cool. The makefile hackery that Cloud Posse has gotten into is I call it hackery with love. There's some good stuff in there. Anyway, so with Atmos, business. Yeah, I don't think it gets it's not a clean thing regardless of how you're doing it, but there's a lot of power there. Anyway, so for Atmos, we have a bunch of, Eric was just mentioning that we're writing tutorials and documentation on all this stuff. And I want to kind of, briefly like cover that. Like we talk a lot about, we're basically calling this whole approach that Cloud Posse has developed that is open source, and that, my consulting firm is using, and I know other people are really interested in using it because what Cloud Posse is like building and open sourcing is really cool. The whole thing is called sweetops. There's a lot of things going on. It's not just the module library that most of you are probably here for, or got introduced to Cloud Posse because of. But there's a lot of pieces to this puzzle that allows full stack automation, which is really cool. The thing that we're going to talk about today is Atmos, which is one of the tools that kind of sits on top of what Cloud Posse calls stacks, and what sweetops calls stacks. So a stack is basically this high-level YAML configuration that allows you to orchestrate many components, and a component is like a Terraform root module or a Helm file. So an Atmos is like it natively understands the stack schema, and then it can then do some fun stuff with that stack schema. And if you're interested at all, we'll post some information, but like I just wrote this up recently, but we have lots of good information on stacks now to kind of drive you and help you understand, hey, what does this thing do for me? Why would I want to use a stack to define my environment?
Can you zoom in on your screen a little bit so it's a little bit bigger?
Yeah, for sure.
Yeah, there we go. Yeah. Perfect.
Yeah. So, and I'll make sure to do that for my terminal and stuff too. There we go. Maybe go a little bit bigger than that.
That looks pretty good to me.
Cool. Yeah, so what I think we wanted to show was we have a tutorial for getting started with Atmos. And I kind of wanted to go through this somewhat in a, just kind of talking through it fashion. You could go and do this yourself. But I think, just showing the high level view of what this tool does and what it enables is really useful. So I'm going to open up, we have our tutorials repository. So that's another thing to show alongside of the tutorials that we have on docs.cloudposse.com. We also have a repo with a bunch of code. So we're going to be going through this one here, and I'm not going to follow it step by step. I'm kind of just going to loosely talk through it while executing some of these commands. But if we're in our tutorials repo and we just do, I've got that up here locally. If we run make run, what it'll do is it runs our tutorials image, which is, for any of you that know Geodesic, it's built on Geodesic, and basically allows us an automation shell with all the tools that we would need, including Atmos, that will allow us to work on this environment without all the problems of, hey, it works on my machine, doesn't work on somebody else's machine. So I'm just going to run this simple make target, which is going to bootstrap that container for me, which I have locally, this Cloud Posse tutorials container, and it's going to mount this this directory, this tutorials repository, into that container. So, and it's a little big, so you don't get the I forget what this is called, the like nice looking thing, but maybe it's fine now. Anyway, so this is our tutorials toolbox. That's what we're calling containers that are built on Geodesic as toolboxes. So now, we have, we're just in a regular shell on this container, and we have our tutorials directory here at the root. So I'll just CD into that and CD into our specific tutorial. So this is the Atmos tutorial. So in this directory, we've got a few folders, and I'll go back to my editor to kind of walk through these. We've got a components directory here that has a number of Terraform root modules. So a component is, there's a bunch of shared components that are reusable root modules, so that you don't need to like reinvent the wheel to create a VPC and a bunch of subnets or something along those lines. We've made some like contrived examples as part of this tutorial that we're going to show, which, this one uses your IP address to fetch your location. And then it uses your IP information to go and fetch the weather data about your location. And then it, very simply outputs it to your terminal. So, what you can do with Atmos is, if we just check out Atmos help, we can see some of the cool stuff you can do. But you can work with a few things. Atmos supports Terraform and Helm file as its main components that it works on, and it also works a little bit with Helm and soon to be Vendor and a few other tools like Istio. But the main thing that we're going to look at is Terraform stuff, because I think a lot of the people from the Cloud Posse sweetops community are really Terraform is king, right? So if we use Terraform, we can use Atmos Terraform to automate some of the simple stuff. And we'll just do a simple plan here where we'll do Atmos Terraform plan, and then we give it the component that we want to plan, like fetch location, and then we provide it a stack. So I have, I was saying earlier, a stack is a YAML configuration that allows you to kind of piece together various components, and Atmos natively understands that YAML configuration schema. And here we just simply list and provide one input for our components that we're working with here. But we list our fetch location component, fetch weather, and output results. So if we specify our fetch location, our stack is actually example example, and Atmos knows that, hey, our stack is going to be specified in our stacks folder. So we'll do this Terraform plan, and what Atmos will do is it starts from nothing. So it'll go and run a Terraform init, which it does here, and then it will create a workspace for you, and then it will run your plan. And yeah, that's pretty simple. Also, we could have just CD'd into that directory and run a Terraform plan, right? Like we didn't provide any value by doing this. So we can see that, hey, we're able to run a plan via Atmos, but what is that actually doing for me? The main thing that it really allows us to do is we can specify all of our configuration for these root modules or these components that we're defining and we're using. And also we can do something cool called workflows. So I'm going to show a workflow real quick where we can specify a set of jobs that we want Atmos to do, and then it will go through executing those various jobs. So if I run Atmos workflow, and I'm going to actually look at the help because I don't know it that well. So you specify a workflow, and then you have to specify a stack. So I will do Atmos workflow, and then we want to do the deploy all workflow, and we will specify our stack. So our stack was example. And what this will do is it'll start going through and executing these Atmos commands in order that we specify. And this enables us, hey, if you follow Terraform best practices of breaking up your root modules, you can now orchestrate them in a really kind of streamlined fashion to help you be able to automate a lot of the pieces, the glue that you might have to write specific configuration around, or specific pipelines around, rather. So instead, now, executing this workflow, we go through, it does a Terraform plan, and then it will immediately apply that. That's what our Terraform, Atmos Terraform deploy command does, is it will plan and apply. So it planned and applied, it created our fetch location root module component that gave back this output information that says, hey, I'm in Boulder, Colorado in the United States. And then our next step, which was fetch weather, uses remote state from that previous component. So it needed to be executed in this fashion because it didn't have the information previously. So it'll go and look up like, oh, I know you're in, because you executed fetch location, I know, you're in Boulder, Colorado. So I'm using remote state from there. And now I can find your proper location and then look up the weather for that. So it'll give me a weather report for that area. And then the last component that we execute is our output results component, which has a variable that we define, and it passes that from our stack configuration here. And that does Terraform init as before, does a plan, and then finally goes through and prints out the weather. This is a super contrived example, but the idea here is that it's showing how you can build on top of root modules and orchestrate them and enable you to define all of that in one location, right? Like this stack configuration file. Eric mentioned, I'm using this with my own clients. I really love this because before, the way that you'd follow best practices, you'd break up all your root modules and so that you have less blast radius. But you don't have a great way of easily defining how those root modules connect or one place to define all the configuration for that. It kind of ends up being this tribal knowledge issue. When you have stacks, that goes away. And this is a super contrived example of what this looks like in regards to a a very like, kind of, this isn't what you would normally use Terraform for, right? This is us, looking for an easy way to not have to enter AWS credentials. But, if we go and look at a more real stack, and this is just something I put together, this is something that you might use for an AWS account. So we have a US West 2 prod YAML stack that, defines a bunch of Terraform components. It has shared, it supports some Terraform null label values like stage and environment and all that stuff. Actually, my environment here, the US West 2, so that the naming for all of my resources would be really consistent. But I define a bunch of components, root modules that I have locally in my project, and this is again just an example. But via this stack pattern, I can define, hey, I want CloudTrail to be watching this account. Hey, I want a VPC with this sitter block. Hey, I want a Postgres database. I want a delegated DNS hosted zone in this account. And I want an EKS cluster running version 1.19. And defining this all in one central location instead of it being spread out across either a bunch of pipeline code or a bunch of variable files that you have to then go and manually apply, or maybe they're sitting in Terraform Cloud or somewhere. Having this all centralized into one location has a lot of power. And also, we're not going to get too much into it. I don't use the Helm file stuff too much, but the stuff that Cloud Posse does in regards to allowing you to install Datadog, stuff into your Kubernetes cluster after that cluster is up, allows you to do things like, hey, I just want Datadog running. I want it to have these tags for this particular account, and then that enables, you're not just dealing with Terraform. You're not just dealing up until the Kubernetes dividing line, and then it's just, you deal with it in your own way. No, you're dealing with it from the perspective of, okay, we build all of our infrastructure, and then when our infrastructure is up, what does our application layer look like? Or the surrounding services before our application layer. So I think that that covers a lot of what I wanted to talk about in regards to Atmos, in regards to stacks. If you're interested in this stuff, we're still building out a lot of documentation, and I'm the one, writing it. And, I think that Eric and I both would love to see a lot of feedback or interaction with the community, because there's a lot of reuse capability here. One thing that's really awesome that I just remembered I really wanted to bring up is we have Cloud Posse has open sourced all of their components. So, and I'm going to the wrong address.
And this answers Emil's question. Can you show an example of those root modules, and how far is a component from a Cloud Posse module? And just to talk to that a little bit while Matt kind of pulls this up. Also, Matt showed, all the 20 pull requests that we have open here, upstreaming more components. Like, we just have a treasure trove of components at Cloud Posse. The only thing preventing us from upstreaming more of this stuff is time. So, but the key thing here to think about, the difference between root modules and that we call components and Terraform modules, is that root modules, first of all, are the top level modules in Terraform. That's what has Terraform state. That's what, persists to an S3 bucket or whatever your state backend is. And then we have modules. So modules, or as Terraform calls them, I think, child modules, don't have specific Terraform state. Now, we write our Terraform modules so that they are less opinionated than your root modules. They're still opinionated in the sense that we always use null labels, so all of our resources are consistently named. But aside from that, we try and make them very just professional, very reusable, very generic, and very consistent. But our components are hyper opinionated. This is the Cloud Posse secret sauce that's not so secret anymore, that we're publishing out there. The components is how we actually build and architect our infrastructure in such a way that we get these building blocks. So when we think about a VPC, here's our VPC implementation. This is what we deliver to actual customers. And we've delivered this same version of this VPC, every year for the last 5 years. And it's continuously evolved and evolved and evolved until what you see here. Some things to note that will bite people in the butt. If you just try and use our components, but you're only trying to cherry pick some of our components, your mileage is going to vary. It's not maybe going to be that effective, because what our components do is that they're very pluggable with each other. So they're reading Terraform remote state. And if you look at one of these pull requests, Matt, let's see what's a good example there, because the pull requests are the most updated versions of these. So let's look at the Aurora Postgres component there, 313. And then why don't you click on the branch for upstream Aurora Postgres, and then go to the modules for that one. Oh, see.
Yeah,
I want to see.
Back.
Yeah. Yeah, and then go to there. Okay, so then you see, click on that remote state.tf file.
Yeah.
So this is really cool because we are using kind of this Cloud Posse Terraform framework that we have, or sweetops framework, is that, well, we understand what a stack is. We understand the convention. And anytime we want to get the outputs from any other root module in this framework, it's super easy. All we do is call this module for remote state, and it knows how to fetch the outputs of any other root module in this environment. That it obfuscates, it abstracts away some of the challenges using the remote state provider, and it makes it easy for anyone else to use. However, if you're not using our stack configs, or you're not using our account module, or you're not using the way we delegate IAM roles and all that stuff, this is where it's not going to work that well with other infrastructures. And the way I talk about this to customers is that it's kind of like the metric system versus the imperial system. They're both great systems. They both produce effective measurements and ways to construct nuts and bolts, but you can't take a metric bolt and use it with an imperial screw. They just don't work together. And that's what we have. So when you use Cloud Posse components, you should use as many as you can. And you should design your personal components that you have in your company to kind of follow some of our conventions.
And I think that, for a new project, I plan on using these. For existing projects where I'm still using stacks, I'm still using this methodology about thinking about things. What I do is I copy, what Cloud Posse has already shipped to multiple clients of theirs that is already, open source. And, I'm able to make a breadcrumb trail back to the open source module or the open source component. And then I just edit it down to what works within my client's environment. And that enables me to, not have to think about how to, it basically makes it so that I can pull a root module off the shelf. I need to edit it a little bit because I maybe don't have the remote state that component requires, but it allows me to bootstrap a big piece of functionality that I might add for a client without needing to do a bunch of thinking myself, or playing with all the knobs and dials to make it tuned to the correct amount. So yeah, these are super useful, but it's not all or nothing. But if you're not using all, then you need to edit them a little bit and make them fit to your use case. But there's still a lot of value there. Anyway, anything else?
That's really great overview, Matt. I like that.
Cool. Anything else we should chat about, Eric, in this regard while we're here?
Yeah, well, just to emphasize one or two more things. One is that you can use Atmos without using any of our components. Our components is how we think about infrastructure as these building blocks. And the desire there is that we as contractors going into engagements really don't always know every situation that we're going to encounter. So what we've tried to do is build something where it addresses almost every single situation that we've encountered, even those that we haven't yet encountered. One customer wants 25 VPCs in one account. Okay, no big deal. One customer just wants one VPC per account. Great, we can do that. You want 2 EKS clusters or 3 EKS clusters in an account, no big deal. So the architecture can be expressed fully with configuration based on the way that we decompose our components and separate the configuration from those. So I think I want to point that out. One other thing is that this YAML config format is, Atmos reads it, but anything can read it. It's just YAML. So we have actually a Terraform module for Spacelift that will then Terraform out Spacelift so that it'll run Atmos or read the Atmos stack configurations. The same thing more or less could be done with Terraform Cloud, but we've had a little trouble with working with Terraform Cloud and some of the limitations there. So I don't know what the current state of that is. All right, that's all I wanted to add.
Yeah, I think that's like a good point or good points. To pull what you're talking about, just to mention it. So if folks are interested in diving deeper, I think that, I don't know, I'm interested, in always diving deeper in this stuff, because it's useful to know the open source stuff that you're using. How is it built so that you can, debug it, but also, what's the secret sauce? What are you actually providing? I think that the provider utils, so there's this module, which Eric just mentioned, which actually is what defines that stack, or what actually reads in that stack, rather. And the reason why that's its own module and not just a, hey, YAML decode, is because that YAML parsing, when you're getting it to the scale that Cloud Posse has pushed it to within Terraform, it's ultra slow. So I think Matt from your team,
Matt
Calhoun. Yeah, he, all your senior guys have contributed here, obviously, but this provider is one of the lower level things that's like the stack configuration is building on top of to make that YAML parsing fast. And it's just providing some simple data sources that make it so that you can do that YAML parsing, or that YAML parsing happens at the Golang layer and not at the Terraform layer where it's ultra slow.
Yeah, and it supports deep merging, which is
something you can. Deep merges, yeah.
That's actually
maybe I was thinking it's the slow part, but yeah. Sorry, go ahead, Matt. Yeah.
No, that's all I was going to say. Is the tricky part was the deep merge, not necessarily the speed of parse.
Yeah, and the generated code you folks had gone through, I saw Andres, work on that, where it was originally there was a bunch of goofy ways to generate Terraform code to deal with that, so you could go 20 levels deep or whatever it is. Funny stuff.
Anyway, we didn't even mention imports, did we? Let's get to Joaquin's question, and then after Joaquin's question, let's talk a moment about import, because I think import is what really makes this so much more powerful in a way that you couldn't do this with just pure Terraform. All right, Joaquin.
So I've used some of the Terraform modules. I would use a different naming configuration. So what I did is I took the code and made my own fork, a version of it, to use my company's naming convention. Because you had some way like the naming convention and prefix and all that stuff, so I changed that. So I really love the modules. Some of the other tools that I saw that was, what I kind of attracted me to Cloud Posse that I thought was really amazing was some of the Helm file and all the other tool sets that are used. And those are just absolutely gorgeous. One of the tools I haven't used yet, but I want to try out, was a chamber, I think it is, for the secrets. Because we have secrets, and we use Git Crippen. It's just a horrid experience, and especially for starters and leavers of the company, it's really hard to manage it across the Git repos. But one thing I really wish, I don't know if you guys know about a tool, or if you're interested in developing a tool or extending Chamber, would be to use HashiCorp's Vault. Our app has facility to use HashiCorp Vault to secure its secrets, but also we're using it in the cloud to secure secrets across the board for infrastructure or platform rather. It'd be nice to kind of use it for code secrets artifacts as well.
So I think my answer to that would be
that guy
now with.
Oh, and one other thing too, in addition to that, any docs or help on customize from that guy in Helm file would be great. He didn't document it. I don't know how to use customize inside Helm files, but he added the feature. He just never got around to document it.
Yeah, okay. Let me talk to those points just briefly. So yeah, so Chamber, I mean, we were big proponents of Chamber and we still use it time to time. Chamber still has a great use case, for example, with ECS, where I think you can't have more than 250 environment variables exposed to an ECS task. We had a customer with 350 environment variables. Don't ask me why. 350 environment variables. So in this situation, we still use Chamber to export those. Now, if you're using if you're using HashiCorp Vault, there's a companion CLI called env console, I believe, also by HashiCorp, that gives you basically the same experience using that with Vault. I've been kind of anti the Vault stuff for one main reason, just that we're trying to get our customers away from managing more critical services in their infrastructure. Now with the managed Vault, maybe that's a solution we'll propose more often as an alternative. The reason why Chamber is so nice is that we can just use SSM as though it were a kind of Vault-like service. Don't get me wrong, HashiCorp Vault does so much more than SSM and ASM. But when it comes down to strictly keeping track of key value pairs encrypted with secure string and KMS key, then it's good. Now, in terms of customize with Helm and Helm file, I remember you brought that up before. It's great. I mean, I like that functionality is there. Basically, customize with a K allows you to monkey patch Helm charts at deployment time. I don't have any, we haven't been using it.
Yeah.
You were the one who raised it to my attention.
Yeah, the reason why is I have no choice, unfortunately. And so what it is as you know, probably in the Kubernetes community, it's like everyone and their brother wants to do an operator. Even though it's completely unnecessary to do an operator, everyone's doing an operator. And so that makes it the nightmare to do dependencies and all that stuff. You know, like one Helm chart depends on another one. Well, now you have like Jaeger depends on Elasticsearch, which requires OpenShift, which requires blah, 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 and so forth. And it's a freaking nightmare. So one of the things I want to do is like, I'd rather just use the Helm chart to put the Jaeger operator, but then if I'm going to use some simple stuff, you know, do a Jaeger customize, because that's what they document. I'd rather just keep it in the Helm file.
Yeah, I don't have, unfortunately, I don't have anything more to add to that. I've been kind of, at Cloud Posse, I've been reducing some of the new stuff we're doing in Helm file, especially for our backing services, and just bringing it back under the folder under Terraform more and more so that we can consistently deploy it with our continuous delivery tools. Now, there is a Helm file provider for Terraform, but it feels like an unnecessary additional layer or provider to get stuff deployed to Kubernetes. The main reason I would suggest using the Helm file provider with Terraform would be just, you have such a massive investment in Helm file that you don't want to walk away from.
The other angle, the use cases they might be interested in is like, I work for dgraph Labs, and we have a distributed graph database. And it's a complicated database. And so one, that's already a complex conceptual burden for a lot of people. And so if I say people might be familiar with Helm and Helm file is just a short step from Helm, I can say, here's how to stitch these three different charts together with dgraph.
Yeah,
but
no, that's nice.
If I'm going to say, go out and learn Terraform to do your Helm.
It's different. Yeah. And I don't know.
If that makes sense.
Yeah, I think I'm not sure who's disconnecting, if it's me or Joaquin. I think it's me.
I talk and then later somehow my mic just go on mute.
Oh, okay.
But yeah, I just want to keep it simple for the customers. Like
yeah, no, I think it makes sense. Helm file eliminates the need to manage Terraform state and all these other things. So there. Well, let's pause there. Matt, do you want to go into the README generator?
Yeah, happy to talk about that. There was one thing I was looking for while you gents were talking.
Imports. Let's cover that quickly.
Well, there's imports, and I'll definitely I want to show that. But the what was I going to show? What's the thing? I thought it was Mamusho who developed it, but the secrets and it supports Vault. SSM. Do you know what that
yeah.
project is called? I forget it.
Yeah, it's the secrets operator is what he calls it.
Was it that it
How-
was?
Yeah, but this was his version. However, I would say kind of like the secrets operator wars is more or less been won by external secrets operator, originally
Okay.
by GoDaddy, and now it's its own organization. So I think that one's pretty cool.
All right. Sorry, I was looking for that, and yeah. Anyway, so let's jump into the README generator. Oh no, let's jump into imports. Yeah.
Yeah.
Cool. So we were just talking about Atmos with this very contrived example. I think that one of the things we can do is look at in our third tutorial where we actually build a AWS environment. We actually have some more involved catalogs, and they're still fairly simple. We build a static site. It's an S3 bucket with a CDN in front of it. But the thing that's useful here is, or useful to show, is that, hey, if you have stacks that run in different environments, or you have globals across all of your stacks, things like if you have the same backend configuration. So one of the things that Atmos allows you to do is you define your backend configuration within your stack, and then you can have Atmos generate the backend config Terraform file for you, so that you can check it into source, follow GitOps, and you're always going to be pointing all of your components to use, all of your root modules to use the same Terraform backend. And that's kind of a tangent, but like, let's say you always have the same namespace across all of your components, or you always have the same region or environment variables, then you can use the stack import, the import key value to specify what you want to import. And that enables you to create very dry and reusable YAML configurations for your stacks, which I think it ends up being really critical, because if you had no possibility to do import when you're managing 5 environments across multiple regions, across with dozens and dozens of variables, it ends up that you repeating a ton of configuration all over the place. And with imports, it does a deep merge, so it'll import the document on top of what you're importing it to, and then you have the ability to share configuration across the board. We need to update our reference architecture. The Cloud Posse reference architecture will show this very well soon, but right now we don't have a great example, unfortunately. This is the best I can probably show, where, hey, we're showing, there's US West 2 globals and just general globals, but there's also component globals and all that fun stuff too. Emil, I think is that?
Yeah, I do have a question.
You have a question?
Like, yeah. If, like, say you instantiate 2 times the VPC, like I saw like there was one example as VPC1, VPC2. Does it mean like you're gonna have 2 state, basically, one for each VPC, and then that's gonna like, how does it? Okay, so it deals with that, because I saw like it does an init, but like if you do an init with another state, how does it work?
Oh, so we didn't show component inheritance. So
virtual
like
component,
static, virtual components. So that's also a really cool thing we can do.
Yeah. So this is in our stacks configuration. I'll post this because I think this is some useful information. And sorry, I'm not following along with the chat, so I hope I'm not missing a lot of stuff. But in the idea where you have 2 VPCs, right? Your VPC name would end up, what the workspace name it creates is the stack file name and then the component name, and that ends up being your workspace. So something speaks to that.
Workspace in the sense of like cloud, Terraform cloud workspace, or in the sense of a workspace Terraform workspace, because those are
Terraform workspace.
Okay,
so
Terraform
the CLI workspace and not
okay,
the
CLI.
you know a separate state file for that. Yeah.
Uh-huh.
So here's an example of that. So the name individual environment stacks file. Oh no, that's not. Anyway, so what you asked about though is like, hey, how does it work in regards to specifying two VPCs? And there's an idea there. We're calling it component inheritance. There's a few names kicking around, but the idea is if you have multiple S3 buckets, for example, that you're creating, then you would specify the top level name as something different for each of them. But then you specify the component that it's inheriting from as component. So, this shows imports actually pretty well, where, in our stacks folder, we have a catalog folder. This is where all your, shared configuration goes. And then you have a component S3 bucket.yaml. And this gives you, the base configuration for your S3 bucket that will be shared across all S3 buckets that you create if you're doing an import. And then in the concrete implementation of using that component, you specify a unique name, and then you just specify the component that you want to base off of that name. So not a common use case, or no, it does come up a lot, but it is something where you're, I don't know, I lost my train of thought, but you're basically dealing with them at a higher level.
So what I would say is your job, in operations, is establishing a platform and the best practices. So what you're going to be doing is creating this library of reusable component definitions, or these snippets, and you stick those in the catalog. So you create a snippet for an S3 bucket, you create a snippet for your EKS cluster, you create a snippet for your RDS Aurora Postgres database, your ActiveMQ clusters, your Redis clusters, all that stuff. You create a whole huge catalog, every service your company wants to deploy. Now, as a developer, I come in, all I do is when I want to create a new environment or new stack, I just use these imports. Okay, look, I want an S3 bucket, I want an EKS cluster, I want an RDS, a Redis database, etc. And then down here under components, then I just override what I want to extend or what I want to set differently. And here you can say, well, what if I want two buckets? I don't want just one bucket. No problem. Just specify public images in the first one, say that it's based off of the S3 bucket component. Then below that, we created the export data, also based off the S3 bucket. And then you notice for one, we changed it from ACL private, which would be the default, to ACL public, since it's for public images. And that's it. Notice we didn't need to touch a line of Terraform code. We can reuse those components as many times as we want. So the cool thing here is that once you have a sufficient library of components in your organization, you get out of the business entirely of writing Terraform every time you want a new environment or thing like that. You're just dealing with configuration. Our configuration is also designed to, it doesn't do fancy stuff like loops and iterators and interpolation, because ultimately our configuration should just be exactly what we want our architecture to be. Anything that needs to be computed, that's the job of the Terraform or the component underneath it. So that's why we don't think in our configuration we need anything fancy.
I think I just came up with a new quote, Eric. Terraform wasn't declarative enough. It's its own language, right?
Yeah.
So
exactly.
the idea with stacks and components is that you're truly just declaring what you need, and your business logic, the actual logic that builds 50 ECR repos or whatever it is all in Terraform, and then the YAML is what is actually defining what's going to go live. This is cool. We have 15 minutes. I do want to get to the README generator
switch
stuff.
Let's switch gears to the README generator.
Cool. So Managed Chaos, which I believe is Michael, has asked this a couple weeks ago, and it's a fun rabbit hole to go down. So I think it's a cool one. And I have somewhere here. links for. So let's, what I want to do is kind of show an example of what, and actually so for a particular, for every repo, every Cloud Posse module that we have in the module library, there is a readme.md, which is this very common looking, not common looking, but very templated, always looking the same across all modules that you always see. And there is a readme.yaml. And this readme.yaml is really what defines the things that are different about this module and defines how to use it, how to, like, what badges it has, what related repositories are there, what's the description, and all that fun stuff. And then it gets composed with Terraform docs to create the common Terraform docs for anybody that doesn't know Terraform docs. It's a project by, they moved it to its own org. Who originally wrote this thing?
Yeah, I forget who it was by.
It was somebody. It was by some big company.
No, Segmentio or whatever. Segment.io.
Segment.
Maybe?
I don't know if it was them or not.
I think
it might have been.
I think it might have been Segment.io. I think so.
Yeah. Anyway, Terraform docs is what creates all this fun stuff. And now I think the
exactly. Yeah. Well, yeah. So Terraform docs creates the Terraform documentation, but then ultimately we stitch all of that together with a template tool called Gauntlet.
Yeah. So what I wanted to really show was the Gauntlet stuff is in the Cloud Posse build harness. And this is all driven by a make workflow. So if anybody has put up a PR against a Cloud Posse repo, we don't do it as much anymore because we automate it via GitHub Actions. But there is, a common theme that we would do was ask people to run make init and then make readme. So what make init does is it copies the build harness into that repo that you're working in, and then make readme actually goes and builds that readme. So it's this way of encapsulating across all of the repos a central set of configuration or a central set of make targets that enable building that. So what make build does, and this is fun, but it runs Gauntlet, where it takes in a template file and it writes out the readme.md file. And if we go and look at that template file, Gauntlet is Go templates. Eric's talked about it a number of times, but it's basically a way to pull in multiple configurations, and very similar to like Jinja templates or Terraform templating. You have a file that you pass some configuration to, and then it creates a output file. So one of the things that is our input is in the repo, we refer to that readme.yaml. So in the Gauntlet template, we pull in the readme YAML as a data source named config, and then we're able to refer to that config to get the logo, or get if the package, if the module is deprecated, then we do a bunch of different information, or if we want to use the description, then we pull that. So this enables a bunch of templating around the same centralized README template. But the fun thing to parse through is, hey, how does that get added with the Terraform docs? So one of the key things there is this. There is a README deps makefile substitution here, where this is a make target that gets run before README build. And what that does is that README deps is defined in each module that we run, that we have a Terraform module in. We override README deps to include building the Terraform.md target, docs/Terraform.md. So it will run and I have the link for this. No, I don't. But it'll run another target. I think I might be doing a bad job of explaining this web, but there's a slight like misdirection kind of going on here. Yeah. But yeah, this docs/terraform.md will actually go and run Terraform docs, and it'll just output into the project's docs folder a terraform.md file that's built off of this module. And then what Gomplate does is it will pull in that terraform.md, like it'll pull in that file and add it so that it is then, it's both a template from the README file as well as those Terraform docs that we're executing as all a part of that one make README target. So
go to the readme.yaml for a Terraform project. And then just search for, I think it's include or.
Oh yeah, it's includes.
Yeah. So here, it just appends those files to this. To the README.
So basically, file. Yeah, this guy pulls in from config. It'll pull in. If the config has an include, then it will go and loop through the files that it wants to include and just include them at this section via Gomplate templating. So. Yeah.
So the original impetus with this was, we have a few hundred repositories. Keeping our READMEs up to date was impossible. Standardizing them was just impossible. So that was one. But the other was that we wanted to keep the information, kind of the documentation about the module in a structured format within the repo so that we could fetch that programmatically from other places later on. So now we have this README YAML file, which is the structured data format that we can query from a centralized place. For example, centralizing our documentation, which is something else that we're working on as well. And the README YAML accomplishes that.
Yeah. So that's the gist. Does anybody have any questions about that? There's also some cool stuff. There is one of the workflows is there. You'll see if you put up a new PR, it's likely in whatever this PR is, but you'll see the Cloud Posse bot, this guy, post an auto format. So the way that we, I was saying 6 months ago, we used to ask people to run make init, make README to try and keep this up to date. And then they would be responsible for adding that as a new commit and pushing it. But nowadays there is a GitHub workflow that automates that. So it kind of, as soon as you push new code, it'll go and check, hey, did they add a new variable that needs to be added to the Terraform docs, which then needs to be updated in the readme.md. And it'll just do all of that automatically. So we don't need to ask people because asking people ended up being, error prone. I ran into issues when I first contributed to Cloud Posse probably 1.5 years ago, where I was like, this make thing does not work for me. I don't know what's going on. But yeah.
One less barrier to contributing.
Hey, Matt, this is Michael. Yeah.
Cool. What's up, Michael?
Hey, I just want to say thanks for going through this. And you actually already answered my question. I was going to ask if you had something that would, as part of a workflow, just like this, commit the code or commit the README back into the repo, as opposed to like forcing somebody to do it. So yeah, that's cool.
Exactly. Yeah. You'll see this in all of the projects. And it's great. I didn't come up with any of this. Cloud Posse did it. I totally used the build harness pattern. I've definitely stolen some GitHub action code. but it's all very much reusable. Maybe tweak a few things, but not too bad.
I was frankly a little bit surprised at how popular the build harness has become. Like, we build it strictly just for Cloud Posse and not necessarily for others to reuse it. This was something that we used to internally. But yeah, it's one of our most popular repos now, and lots of people have contributed to it. And I thought people would hate on Make a little bit more than but they didn't.
People need glue. I think that the build harness provides some powerful glue.
Yeah.
I used it, I've implemented it for one client because they're a microservices shop. They've got 30 to 40 repos, and, the GOM plate templating pattern of, making it and then make template is really powerful for automating or keeping things up to date from a centralized configuration. Like, if you're doing any sort of GitHub action, provided template or anything like that, the build harness pattern is pretty solid.
Yep. Mohammed was asking here, I strongly push toward making Atmos modular by adding daily TF tools based template or tutorials. Mohammed, can you talk a little bit more about what you were pointing at there? Mohammed, do we still have you?
Yeah, can you hear me now?
I hear you now.
Yeah, so let's say I want to add a new tool, for example, generate a diagram or something. Can I add it to Atmos? Is there like steps how we can, integrate our daily tools there?
Yeah, no, that's a good question. So we did build that Atmos with that in mind. It could be, I'll be honest, Atmos is built on a tool called Variant, and it means you got to learn Variant first. And like with most things, including our Make, everything we do is a master class in whatever that tool is. So with Variant, this is a master example in that. So if you go into Atmos and modules, this is kind of where you would add your own support for any other tool. And you just define, the point with Variant is to define workflows essentially in a language agnostic way. I mean, it's still a language, but it's not beholden to Python. It's not beholden to Java. It's not. So this is like this third category, and that's why I like it. So here we've implemented the commands for like Terraform. And what's cool about Variant is that you write your code in something that looks like HCL. So it's this declarative way of defining your workflows. And then if you click on the Atmos folder at the top there, the second Atmos folder in the top there, click on main.variant, and you can see that we just scroll down here at the bottom. You see these imports. So you can refer to local. I hate Siri headphones, or these Apple headphones. SIRI, stop popping up. Anyway, sorry, distraction. You see these imports here. You can refer to a remote repo here, just like you would in Terraform. So you can import modules from a remote source or local source. And Variant can be compiled to binary because it reduces to Golang, and then you can cross-compile it for multiple architectures. So now Atmos is distributed for multiple architectures as well.
Yeah, awesome to know. Thank you.
Okay, yeah. All right, I think we're basically out of time for today. Thanks, Matt, so much for presenting all of that information. Again, Matt is with Masterpoint Consulting, and it's been a phenomenal help for Cloud Posse in documenting or updating our documentation. So I appreciate that. Thanks a lot, Matt. All right, so everyone, if you haven't already, please head over to youtube.com/c/cloudposse and subscribe to our YouTube channel. It's a big help for us so that we can increase our level at YouTube. They require us to have a certain number of subscribers before we can do certain things there. So appreciate it if you subscribe to our channel. Also, if you haven't already joined our Slack team, go to slack.cloudposse.com. I think we're almost up to like 3,800 members now. It's pretty awesome to see the growth we've had over the past year. Super helpful community. Also, feel free to reach out to me and schedule time to talk to Cloud Posse to see how we can help you out. Go to cloudposse.com/quiz to kick off that process. Talk to everyone same time, same place next week. Yeah, have a great rest of your week. Bye-bye.
See y'all.